Welcome to I Love Science Virtual Family STEAM Night, hosted by Scientific Adventures for Girls in partnership with Chabot Space and Science Center. I'd also like to wish everyone a happy International Day of Girls and Women in Science. That is today, so double celebration going on. My name is Mariana, and I am the Family Engagement Specialist and Head Teacher at SAFG. Scientific Adventures for Girls is a nonprofit that provides after-school science programs to TK through 6th grade girls to increase positive attitudes towards science, technology, engineering, and math, also known as STEM, and increase hands-on learning opportunities and encourage lifelong learning of STEM subjects.
And I'm Haley. I'm a science educator at Chabot Space and Science Center. Chabot Space and Science Center is a science center featuring exhibits. We have some telescopes, we even have a planetarium, and a lot more. And we're located up in the Redwood Regional Park up here in the hills of Oakland. Our mission is to inspire and educate learners of all ages about the universe and planet Earth.
The theme for tonight's event is I Love Science. So we will be celebrating all the things that we love about science and all the ways that science helps us love the world. We want to know what you love about science. So go ahead and put in the chat something that you love about science. What's your favorite thing about science? What do you love? Go ahead and put in the chat.
What do you love about science, Mariana?
I love the technology that science gives us to use TVs and use cars and to talk on the phone. I think that's really important, especially now, to stay connected with people.
Nice. Some of our friends in the chat love planets. They like that there's always more ways to learn. We like to make things. Ooh, like to figure out how things go together. I like that kind of science too. I like engineering. It's pretty fun to figure out the solution to a problem when you're given something challenging. We like magnets. We like experiments.
Love experiments.
Stars, yeah.
Yeah. What do you love about science, Haley?
Well, I like engineering, but I also love food science because cooking is like science in its own and baking. So every time I'm in the kitchen, I could be wearing my lab coat because I'm doing science. So if you like to cook, you're basically doing science. So something I love.
Awesome. Planets and stars. Yes, I love everything in nature too. And that's part of science because you can study it. Wonderful. Building and cooking. Great. Awesome. Thank you so much for sharing. So I also want to share with you that during this event, we'll be guiding the children in the audience through a series of interactive science activities that celebrate what we love about science. We will also be asking the adults in the audience to participate in 3 different polls throughout the event. So please stick around and keep an ear out for your call to action when it's time for the polls.
If you did pick up a STEAM kit before tonight's event, go ahead and make sure to grab that now. We've got a few minutes before we actually get started. That kit's going to contain most of the materials that you need to follow along with us at home. If you were not able to pick up a kit before tonight's event, you should have also received a confirmation email that had a list of all the materials needed. Most of those materials you might be able to find at home. We also can post a list of all of those materials in the chat right now. So if you would like to, you can use the next few minutes to try to gather as many of those materials together as you can so that you can follow along. We're also going to be recording this event and sending it out at a later date. So if you're unable to follow along with the activities while we do them, if they're moving too quickly, or if you just want to take your time to watch now and do later, you can always look back at the video and follow along at a later time. The I Love Science event is going to last about 1 hour long. And at the end of the night, we're going to be raffling off several exciting prizes. You should have seen a list of them in the confirmation email, so you already have a sneak peek. However, you must be present at the time of our raffle in order to win those prizes. So make sure to show us some love, to stick around, and have a chance to win some fun prizes and to do some science.
But now we'll bring it over to Haley, who is live from Chabot for our first jaw-dropping demo. Take it away, Haley.
Thank you, Mariana. So I am actually here at Chabot. So if you've visited before, you may recognize the background. We're going to get into something that I love when I do science, and that's doing big demonstrations. And the demonstration I'm going to do today is with fire. I really, really like fire because it can show us a lot about chemistry and it can show us a lot about reactions. Now, because this demonstration is going to be with fire and it's going to be dangerous, this is a demonstration that you will be sitting and watching at home. This is not an activity that you'll be following along with, but I will need your help to answer some questions that I'm going to have. And you can always type in your observations in the chat of what you see, what you notice, or any questions that you have. So this is going to be a demonstration for you to watch, you to enjoy, but not necessarily to participate in. Hopefully you're okay with that because it should be pretty fiery and pretty exciting. So today, in front of me, I have these 5 different test tubes. And there's 5 different ones, and each of them is filled with a flammable material called methanol. Now, you may not have heard of methanol before, but you may have heard of the word flammable. So when you think of the word flammable, what comes to mind? Do you know of anything that is flammable? What does it mean for something to be flammable? Ooh, nice. I'm saying fire, 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 fire. Oh my gosh, everybody's on the same page. Yes, if something's flammable, that means that you can light it on fire. Now, when you think of lighting something on fire, we typically use fuel like sticks or logs or gas or something like that. And when we make a fire, what color does a fire usually burn? What colors do you see when you see fire? Go ahead and type in the chat. Sometimes we see red, sometimes we see orange, sometimes we even see blue, yellow, red and orange. Yeah, we typically see colors like red, orange, yellow, maybe even blue and white. And those colors are really common for fire to be because when we burn fuel like wood or paper or coal and oil, those are usually organic materials. And organic materials have these cool elements in them like carbon, oxygen, and hydrogen. But these 5 test tubes in front of me, filled with flammable methanol, do not have organic materials in them. They don't have carbon or oxygen or hydrogen. They have special element salts. And these element salts are made up of different elements. And I want to see what happens when we burn these materials because they're not organic. I want to see what kind of fire they make. So I'm going to turn the lights down and we're going to light each one of these on fire to see what color that they burn. If you'd like to, you can make a prediction in the chat what color you think you're going to see. And then when I light them on fire, you can type in your observations of what colors you are seeing. So give me just a minute. Turn the light down a little bit. And let's get started with one of our elements. This one is called strontium. Let's see what color strontium burns as. Ooh, go ahead and type in the chat. Can you see what color strontium is burning? Kind of like an orangish color, a little bit of pink, almost a pink color. Yeah, strontium has like a little bit of a pink, a little bit of an orange. Let's see about sodium. You may have heard of sodium before. Table salt has sodium in it. Let's see, what color does sodium burn? What color do you think that is? Yeah, sodium burns a really nice, bright, yellow orangish color. So this is almost really close to what we typically expect for fire. But sodium has a much stronger yellow color. Really, 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 really strong. All right, now we're gonna burn an element called potassium. Ooh, what about potassium? Does potassium even have a color? What color would you say that is? Kind of like a white, almost like a peach. And then at the end here, you're seeing this yellow color because that's the stick burning. And the stick is like an organic material. Let's do lithium. This is our 4th element. What color would you say lithium burns? That's a quick burn. Yeah, kind of like a pink, kind of like a red. And then here's my favorite one. This one's copper. What color does copper burn? Yeah, copper's got this cool green turning into blue, almost like a white. And then you'll notice it starts to look orange and yellow as the stick begins to burn. So we've got lots of cool colors that we're burning here, but have you ever seen colors of fire like that before? Is there anything in your life where you've seen colored fire? And I'd like to know if you have any guesses. Yeah, fireworks are a really good example. If you've seen fireworks, you've seen colored fire just like this. They actually use different element salts in fireworks to give them a color when they burn in the sky. And I love fireworks. I think they're really cool. You've maybe seen blue on the stove in camping. Maybe you've seen colored fire before if you have fun little things to throw in there. Yeah, blue is really common as well, maybe in birthday candles, orange on the stove. Yeah, so we do see colored fire a little bit in our day-to-day life, but some of these colored fires are really special. So why do you think, or do you have a prediction, why are these elements burning different colors? Why are they not just yellow and orange like we typically would expect? Does anyone have a guess? Maybe they burn at different temperatures. Maybe they're burning off different gases. Maybe there's food coloring in them. These are good guesses because they're not organic, different gases. They're on wood and they're different. Yeah, it's as simple as the fact that these elements are different. Because they're not organic, like carbon and hydrogen and oxygen, that means their atoms are different. Now, if you've heard of an element before, you may have heard of an atom. So, elements are the building blocks of life, and they make up everything around us. Elements can be combined to make new materials, or they can be in their pure form, such as oxygen and hydrogen that are in our air. But when we think about elements, if we could zoom in, we might be able to see an atom that looks like this. And an atom has protons and neutrons in the middle and electrons on the outside. It doesn't really matter that much about these guys, but what we need to worry about is these electrons, because the way these electrons circle around these tiny invisible atoms can affect how elements interact with the rest of the world around them. So each of these test tubes have a different element in them, and those elements have a different formation. You can imagine they're all built a little bit differently. When we light them on fire, we're actually adding energy. So we can imagine that this is our little electron sitting outside of an atom. Let's say it's lithium. When we add energy to this little electron, it gets really excited. Just like when you have energy, you might get really excited. And so that electron, it jumps. And it actually jumps from where it used to be to a higher energy level. But just like you and I, if we jump up and down, we're always going to come back down. And so, just like we do, the electrons fall back down. And when they fall back down from where they are when they're excited to where they rest, they actually give off light. Because the energy that they gain, they can't hold on to it. It makes them too energetic, just like me. I need to take a nap after I use all my energy. So when those elements are getting lit up, that extra energy causes them to give off light as they move back down. So when we burn something like lithium, those electrons are getting excited, they're moving around, they're jumping, and when they're falling back down to their state of rest, they're giving off light. The different colors of light are caused based on how that jump looks. If it's a really big jump, that might be giving off high energy wavelengths of light, which would create something like potassium's color. Purple and blue, those have a higher energy than something like strontium, which burns more of like a red. So the color of light is not only due to the electrons in each element, but they can also tell us a little bit of information about the energy of that light. So when you hear that the blue part of a flame is the hottest part of the flame, that is true because it has more energy, and the color of the light can tell us that. Now, we're gonna do one more thing after I burn the rest of this copper. And that is because this is an I Love Science night, I wanted to see if I could make a big burning heart. So I decided that I would make some pipe cleaner hearts, and I wanted to choose a color to burn them. And I was thinking we could go for maybe like a red color. So does anyone remember which of these test tubes, when we burned them, made like a red flame? We have lithium and strontium, we had sodium, potassium, and we had copper. Does anyone remember which one was kind of like a red? The first one, potassium, sodium, strontium. The fourth one, I did kind of go all over in order. Potassium was kind of like a purple. Let's try lithium. Lithium had that nice reddish color. So I'm going to take some of my liquid, which has methanol and lithium. And I'm going to pour a little bit in here. Just a little bit. Remember, methanol can be very dangerous. And I'm going to take my pipe cleaner heart and I'm going to dip it in there. And then go ahead and give me a prediction. What do you think is going to happen when we light it on fire? Any predictions? Trying to make sure it's nice and coated for you all tonight. All right, hopefully we get some red flames, but let's see. Let's see if we can get them. All right, I'll hold it nice and close. Let's see if we can get the red burning heart of love that we needed. Ooh, half of it's still going. Only half of my heart burns for this experiment, I guess. Wow, burning heart. And now it has burned out. More fire. Should we do one more? Should we make a green heart? I think we should make a green heart. A broken heart. All right, let's do one more. We'll do it with one of these got kind of wet. Let's see if this one will work. Yes, let's try to do with a green heart. Let's see what we can get. All right, this will be my final demonstration of our I Love Science demo. And then remember, in our next upcoming activities, you will actually get to do them. This one, however, is a just watch demonstration. All right, let's see if we can get a green heart burning for science. Uh-oh, got a little wet. Ooh, only some. Yes, we love science. We love using science to make some fun fire. Alrighty, friends. So, don't worry, we do have a fire alarm here at Chabot, and I do have a fire extinguisher here with me on hand in case of an emergency. But for now, I'm going to hand it back over to Mariana to get us going with our first hands-on activity. Hi, for our first hands-on activity of the night. So grab your I Love Science kit and make sure to take out the following materials for the Cupid's bow and arrow activity. You're going to need paper clips, you're going to need rubber bands, and you're going to need cotton swabs. And I think that's it. So thank you so much for sitting through our demonstration. Hopefully you enjoyed it. And let's see what Mariana has for us over there at Scientific Adventures for Girls.
Yes, thank you so much, Haley. That was really cool to see the different color flames. So for this activity, everyone, we are going to be making a mini bow and arrow, which in the end might look a little something like this. You can think of as Cupid's bow and arrow. Before we start building though, I do want to talk to you about energy, because this project, you need to kind of know what energy is, because we're going to be using it in this project. So what are some things you can put in the chat that you need energy for? Maybe you need energy to play a sport or walking your dog. What do you need energy to do? Sleeping, that you go to sleep so you can get more energy. You can't stay up forever. To go swimming, to go running, yes. Yes, you definitely need energy to stay awake for school and for work. Basketball, yeah. Oh, someone said eating, which is very interesting. I'm going to talk about that. Playing soccer, perfect. Yeah, walking the dog. Yeah, all of these things you need energy for. Thank you so much for sharing. You also, if you didn't know this, you need energy to grow. If you didn't eat enough food, so food is what gives us energy, you wouldn't be able to grow. So animals need food, humans need food, plants need food. That's how they grow and get bigger. So all of those things, all the food gives us energy, and we use energy to grow and to do things. But what's something that you might not have known is that people and animals and plants can have energy, but objects can have energy as well. So I want to first go over the definition of energy, because you're like, objects can have energy? What? So energy is the ability to do work. So when you're picking up something heavy or even just moving something, you're exerting energy, because that's the ability to do work. But there's also different types of energy that an object can have. So if you're holding something in your hand, that object actually has energy. So if you throw an object, like a ball, or even when a bus or a car is driving down the road, that has kinetic energy. Kinetic energy is energy of anything in motion. So when anything is moving, it has kinetic energy. So when you're throwing something, yeah, you're running really fast, you have kinetic energy. But there's a different type of energy called potential energy. And potential energy is stored energy in an object. So before it starts moving, like maybe a rock at the top of a hill, if you push that rock, give it a little bit of energy to go forward, boom, it's gonna fall really far. So it has the potential to release energy. If you have a balloon filled with air and it's not tied and you're just holding it, but then you let it go, it's gonna start flying. And a flying balloon has kinetic energy, but a balloon full of air has potential energy. So in this activity, we're going to see how our object has potential energy, and then we'll have kinetic energy when it's flying through the air. So let's go ahead and get started. First, you will need your paper clip. And if you have a big one or a small one, either one is fine. And I'll move my camera so you all can see. And your paper clip, you want to stretch it or unfold it so it is really long. This might take some energy to stretch it out and stretch it out. You can try to get it flat. Oh, this is a little bit hard, but you're going to actually bend it back again to make almost like a very skinny C, and I'll show you what that means. So you want it up, flat on this side and flat on this side, but a very long flat part in the middle. So almost like maybe a really wide U. All right, and this is the paper clip that we're unfolding. Now, this part is actually really hard, the next part. You're gonna have to fold these little ends backwards. And I'll show you what I mean by that. You might need some grown-up hands to help with this, but you wanna make it look something like that. And backwards one more time on this side. So you end up with this very wonky looking paperclip that you stretched out. Now it is time to add our rubber band. So I have a big rubber band here. You can try different sized rubber bands. Maybe you want a smaller rubber band if you're using a smaller paperclip. And you're going to stretch the rubber band so it goes like this. So it's caught in between the little folded ends of the paperclip. And if you want to make this rubber band secure, you can even squeeze the ends a little bit more so that your rubber band doesn't fall out and slip out of here. Cool. So now you should have something kind of like this, a rubber band that is stretched across the stretched out paperclip. All right. Now, before we add our arrow, this is our bow for our bow and arrow, and you can pull back on the rubber band and feel it stretch and let go. So when you're pulling back on this rubber band has potential energy. If you let go, it's going to move, and if your finger was there, it might even snap it, and you would feel, ouch, that kinetic energy might hurt your finger. So if you pull back, that's potential energy, and release it, and maybe it vibrates a little bit, and when it's moving, that is kinetic energy. But let's see what happens when we add another object to our bow. Let's add an arrow, which is your Q-tip. So with your Q-tip or cotton swab, you can hold it with 2 fingers, kind of pinch it between your thumb and your pointer finger, and hold it in the middle of the rubber band. So it's perpendicular, if you know what that means, perpendicular to the rubber band. And with your other fingers, hold onto your bow, to the paperclip. And then hold it back, pull it back. Ooh, you might feel the tension. Now this arrow has potential energy, because if I release it, it will go in motion. So let's see if you can see how far it will go. Whoa, that went really far. That went all the way across the room. So yeah, oh yeah, if you have a hair tie, that could work too instead of a rubber band. Yeah, there's a bunch of different alternatives you can make. So you can try that again, maybe angle it upwards or try to pull it back even farther. How far can you get it back? This is a really cool activity. I won't throw it again because it's gonna go all the way across the room. But another activity that you can do, or to test it, is to try to get a different size paperclip. So if you used a big paperclip, make a different one with a small paperclip and maybe a smaller rubber band. I made one here, and see how they're different. Does one make the Q-tip go farther than the other? What happens if you use a small rubber band on the big paperclip? Does that make it too tight? What's going to happen? So you can make some observations, maybe collect some data, and see how far your Q-tip will fly when you use it with your little bow. All right. So thank you so much, Archer engineers, for building our bow and arrow and learning about potential and kinetic energy. Now I will pass it back to Haley to tell us what's next.
Thanks, Mariana. That looked super fun. And if any of you out there were having a hard time making your bow and arrow, remember that we will send this video out to you later, or you can always just try it at home, try to figure it out. That's one of the best parts about science. Sometimes you just got to figure it out, or maybe if you have an adult nearby, you can ask for their help. But that looked really fun. I can't wait to try one out myself. But for now, we are going to switch it up a little bit. It's time to get your hearts pumping with a dance party intermission featuring a music video mashup from Chabot's resident DJ. His name is DJ B1, and he's an artist from the Bay Area that makes music videos mixed with music that he makes. So it's kind of some visual, some audio, fun experience, and this one is wild. So we're gonna have a little bit of a dance party in just a few minutes. During this time, we are also going to send out a poll. So for all of the adults out there, we're going to ask you to help take this poll while our music video intermission is playing. Please fill it out as best you can and then press submit. There is about 4 questions on it. So kids, if your adult's not in the room, go ahead and grab them just for this little poll and get ready to do some dancing.
Yes, and one more thing, Haley, that I want to share with everyone. So for the kids, we'll not only be dancing, but we'll be taking part in a science experiment involving our hearts. So you probably know that your heart is a very important part of our body because it helps pump blood to all the other parts of our body, up to our head and down to our toes and out to our fingers. So does anyone know where you can feel your heartbeat or your pulse? Where on your body can you feel a heartbeat or a pulse? Ooh, I see wrist, your neck. Yes, on your chest. Yep, so that's where your heart is. Yes, a lot of you know, yep, you can feel your heartbeat right on your chest. And if you are really careful, if you use your fingers, you can sometimes feel it on your wrist right here. And also the pulse is very strong on your neck. You have a lot of blood going through there. So if you feel your neck, you can feel your pulse there too. And fun fact, there's also a pulse that you can actually feel on your foot. That's very hard to find though. So maybe you can get curious and try to find where's the pulse on your foot. All right. So, but for this experiment that I want to do with you all, I want us to measure our heart rate first before we start dancing, and then we're going to measure after we start dancing and stop dancing and see what the difference is. All right, so I will count. I'll put a little timer on for 30 seconds. It's going to feel like a long time, but I'll let you know when it's over. And I want you to just count how many beats you feel of your heartbeat. You can feel it on your chest or find it on your neck and feel it there. All right, so let's start counting. Feel your pulse. Start counting now. Just breathe deeply. Now take a quiet moment. And stop. All right, stop counting. So whatever number you got to, I want you to multiply that number by 2 or add it together. Awesome, I see someone got 34. Wow, 2 people got 34. 41. All right, I'm gonna choose the 38 number. Whoever got 38, we will use yours as an example. And you can multiply by 2 or just add it to itself. So you're doubling that number. 16, 76. So whatever your number is after you double it, that is your beats per minute. That is your heart rate, also known as BPM, beats per minute. All right. Ooh, I see some. So if you want to, after you multiply it, you can share that number in. Oh, someone got 90. Yeah. Cool. So remember that number. Don't forget it, whatever it is that you got. And we will do this again after our dance break and see if it changes. All right. So let's go ahead and get our poll going and start our dance video. Get ready to do some moves. All right. Warming up, warming up. Shake your arms, get ready. Thanks for doing our poll. Cool. Cool, I see those poll numbers coming in. Thank you so much for completing the poll for us. It's very helpful. If you see your favorite animal in the video, go ahead and put it in the chat. There's some really cool stuff flying through that video. Ooh, a snake, a bat, I see a bear, watching TV, wearing sunglasses. What?
The wild animals are wiser than we.
Cool down moment, cool down.
In the day, endless colonies.
A frog just ate that other reptile. What? This guy eats an alligator. Sea creatures. Are these sea creatures? Ooh, already feel your heart rate going up? Maybe you can check it. Is it beating faster already?
Actually, the fall of Matthew is his venture into technology.
Oh, I saw my favorite food. I saw some pizza. There's that volcano again.
And we just don't realize, because of this tremendous preoccupation, we don't realize how beautiful we are.
Whew. All right. So quick, before anything happens different with our heart rate starts to go down, let's go ahead and take our pulse again. Find your heartbeat on your chest, maybe up on your neck, and start counting now. Whew. Mine's going really, really fast. Keep counting. And stop. All right. What numbers did we get? Let's see in the chat. How many beats did you get in 30 seconds? Let's see, I see 50, 44, 63. Whoa, 103. Oh my goodness. All right, I'm going to use the 70 as my example here. 66, 73. Oh my goodness, a million.
Our hearts were racing.
Yes, so much. So whatever number you counted to for that 30 seconds, go ahead and double it, add it to itself, and you should get your new heart rate. So if this were mine, it would have went up from 76 to 140. Yes. Awesome. I see 180 beats per minute, 140, 100. Nice. Getting that heart rate up. Thank you everyone for participating in that with me and moving your bodies. Now I'm going to hand it over to Haley for our next activity introduction.
Yeah, so we are actually going to be handing our next activity off to two of our teen volunteers from Chabot Space and Science Center's Galaxy Explorers program. Now, this program is really cool. We call it the Galaxy Explorers, and our Galaxy Explorers, we call them GEs for short. But this is a high school volunteer program, and GEs come from high schools in Oakland and all over the Bay Area to participate in fun, hands-on community service work. They get to develop job skills, and they get to increase their STEM knowledge. We're actually accepting our new class of GE applicants right now. So if you know someone who's in high school who likes STEM and maybe likes space, but doesn't have to like space, you can actually apply to be a Galaxy Explorer right now with Chabot Space and Science Center. So tonight you're gonna get to meet Sage and Taylor. They are two of our awesome Galaxy Explorers who worked together to create the next hands-on activity that you're going to be doing tonight. So go ahead and grab your water filter activity materials from your I Love Science kit to get ready. That includes the coffee filter, cotton balls, gauze, the snow cone cups, rice, and the sprinkles. You're also going to need 2 cups from home and food coloring if you have it. And just a quick note, this video is a little fast, so you can use this first viewing experience as a source of inspiration for when you do your activity later, or you can use it as a way to just get started and then finish the activity once our event tonight has ended. Remember, we're going to be sending this video out to you later, so you can always rewatch it back and do this activity again later. But for now, I'm going to introduce Sage and Taylor, who should be here, so they can come on screen and they can tell you a little bit about themselves and what they love about science before we watch their video.
Hi, I'm Taylor. I'm a Galaxy Explorer. I go to Carondelet and I help to make this video. And one thing I really do like about science is that we're constantly learning, and just there's never a stopping point to how much knowledge we can get.
Hi everyone, I'm Sage. I'm in 10th grade and I go to Piedmont High School. And what I love about science is probably like exploring the universe. It's pretty cool.
So we prepared a video, and I'm not sure. Okay, yeah, so it's starting.
SpaceX Dragon, we're go for launch. Let's light this candle.
3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX.
America has launched. So rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream. 20 seconds into flight, stage 1 propulsion is nominal.
Hi, my name is Sage.
Hi, I'm Taylor.
And we are both Galaxy Explorers from the astronomy team at Chabot Space and Science Center.
So we're going to make a water filter. Not only are these things used by people like you and me every day when we want a glass of water, but they're also used in space. Just think about it. Besides going right back to Earth if you're thirsty on the International Space Station, where would we get water?
Well, astronauts on the International Space Station use filters that extract clean, drinkable water from their sweat, condensation, urine.
Wait, did you just say urine?
Yes, actually pretty gross, but astronauts actually use any available resource that's liquid at the space station. Our water filters won't be as fancy, but if you're interested in trying to develop a new water filter for astronauts, I think this might be a good start for you.
Now, without further ado, let's open that kit and make a water filter.
Okay, here's what you need. You need rice, a coffee filter, a cotton ball or a disc, gauze, snow cone cups, heart-shaped sprinkles, and if you have food coloring, I will add that in too. And also, you need 2 cups.
Step 1. Use 1 cup to fill with water and add in heart-shaped sprinkles. Also, if you have food coloring, add that in too if you want. Step 2. Mix heart-shaped sprinkles in water until most of it is dissolved. Leave this cup of dirty water to the side for a moment. Step 3. Okay, so now let's build the water filter cartridge. Carefully cut the tip of the bottom of the snow cone and place a coffee filter inside the snow cone so the coffee filter's tail is at the end of the cone. The space station has many stages that start to filter out larger remains in the water filter. Mix and layer the materials such as cotton balls and rice. Now go grab a piece of paper and start designing how you want your filter to look on the inside. Write down all the materials you want to use so you don't forget any. Step 5. Okay, now we can put it all together. Add all the layers to the top of your filter cartridge. Step 6. Use of wastewater. After you put all of the layers inside your filter cartridge, set up the cup without water on a table. Put your water filter over the cup as you slowly pour the dirty water through the water filter. And now here's the final step, the test results. Observe the water that comes out at the bottom of the filter. Is the water clean? How long did it take to filter the water? What can you do differently to improve the color?
This took us to the end of the video. Thank you so much for watching, and always remember to never stop exploring. Bye!
Thank you so much, Sage and Taylor. That was a really cool video, and I just learned a really interesting fact that astronauts filter out their own bodily fluids to make water on the International Space Station. That's pretty interesting and kind of yucky, but that's okay. Science, I trust the science. Just for all of you out there, if you're still working on your water filter activity, don't worry, you can continue to work on it for the next few minutes, or you can use the video as a source of inspiration to get some ideas. And remember, you can always go back and watch this later. And I didn't see any questions in the chat. Okay, now there's one. There is a question that is, do you really mean that they drink their own filtered pee? So Sage or Taylor, do either of you want to answer that question?
I'll answer it. They do. I looked it up. I was appalled as well, but they very much do drink their own pee. It's like if you imagine somebody lost out in the ocean, they need to filter out the dirty stuff to get to their own pee because there's only a finite source, you know. Not everybody just has water bottles and like lying around. They can't go to the grocery store. They're in space, you know.
Yeah, and they also use like any available liquid resource that they have at the International Space Station. So pretty cool.
That is really interesting, but it makes sense. Space is a really tough place to be, so we have to figure out new ways to get around that. So if any of you at home come up with a really good water filter, maybe you should send it to NASA. Send your ideas over there and they can use it to make up a better water filter. We do have another question. Where does all the bad stuff go? Ooh, do either of you know?
Okay, this is speculation, so I don't 100% know. You should always fact check people, but I'd assume that they have some sort of like filtering system like what we just made, so that think of it as the filter as some sort of colander where all the bad stuff would get stuck and all the good stuff like the water would be separated from it. Yeah.
Yeah, that's kind of what I would think too. And they have all of the stuff left over. Eventually they have a lot of stuff left over and they have to do something with that. So who knows? And then one more question before we move on to our final activity event is, do you have any suggestions for the best material to filter out the dirty water? Based on your tests, did you feel like there was anything that was more successful or a little bit more challenging?
I think the gauze is pretty good. What do you think, Taylor? I think the gauze is the best one.
Sorry, my audio was acting up. Yes, I think the gauze is probably the best one out of the materials that were available to us.
Mm-hmm.
Yeah, no, the gauze is the best. I agree with Sage.
All right, so it sounds like gauze is a good filter, but remember, you can always add more materials. So if you're working at home and you have an idea, maybe you want to try a different filter, you could always do that. You're doing real science that way. You're actually experimenting with your own hypotheses, your own guesses, and you can write down the data and you can share it with us. So yeah, always use your imagination. It's a great way to do things. So thank you so much, Sage and Taylor. Everybody say thank you to them. We appreciate your work. Two of our awesome galaxy explorers here at Chabot Space and Science Center. And if you're interested in learning more about the GE program, feel free to check out our website. You can find out more information there, and you can support really cool teens doing really cool stuff. So thank you both.
All right. Thank you so much, everyone, for staying till the very end. Congratulations to all the raffle prize winners, and thank you all for joining us and helping us in our poll. And shout out to Chabot Space and Science Center for collaborating to put on such an exciting event with us at Scientific Adventures for Girls. Feel free to check us out on our social media pages like Facebook, Instagram, and our website, so we can continue to bring you science into your homes. Awesome. And check out Chabot Space and Science Center as well on all social media.
Yeah, feel free to check us out. Feel free to visit when we reopen. We're closed to the public right now, but thank you so much for joining us on these online virtual events. And yeah, feel free to check us out online. We've got lots of other events that happen. But we want to thank Scientific Adventures for Girls for inviting us to be part of this event. And hopefully you all had fun and hopefully you enjoyed doing some science tonight with us. We love science. Ah!
Yes, we love science. We hope you do too. All right, and check your emails later for a follow-up email if you have any more feedback to give us directly. And we'll also be sending out the recording of this webinar for you to rewatch or share with friends and family. All right, bye everybody. Thanks for being here.